Hey guys, so today we'll talk about chapter 4D and E, interior and exterior angles of a polygon. So the last video, it was just a big review on angles and angle properties and some triangles. So today we'll talk about new stuff. So what I want you guys to do right now, grab a piece of paper and a ruler and a pencil. So in all triangles, the interior angles add up to 180, and we already know that. So I want you guys to draw a triangle on your piece of paper right now. Okay. All right. And then that's the first triangle that I drew, the pink one here. And if we add another triangle onto the existing triangle, what happens to the angles? So you might add another triangle right here, as long as attached to these. You could also put it here, or you could also put it here. Whichever, doesn't matter. Alright, so what happened to the shape there? What do you think? So I want you to write that down really quickly. What do you think happens if I attach one triangle to another? What happens? So maybe you said, okay, it's no longer a triangle. I mean, you're right about that. It's not a triangle anymore. Okay. I want to focus on the angles here. So what happens to the angles, right? So the sum of the interior angles of this new shape will be 360 degrees. And you may think, okay, that's easy enough. That's 180. That's 180. So we add them up together. Exactly. So what if we do it over and over again? Okay. So this one here, it has 1, 2, 3, 4 sides, right? So the number of sides are 4. So we have 2 triangles. And then the angle sum of this polygon here is 360, because 180 times 2. Okay. What if we add another triangle? So what if we add it like this? So that means we have 1, 2, 3, 4, 5 sides, which is a pentagon. Okay. The number of triangles is 3. So that means we have 180 times 3. So that is 540 degrees. And we're going to go on to a hexagon, which means we have 4 triangles now. Okay, we have 4 triangles. 1, 2, 3, 4, 5, 6. 4 triangles. And then it has 6 sides. So again, if you have 4 triangles, just multiply by 180, right? 720 degrees. So by now I hope that you see a pattern here. So it turns out there's a formula. From that pattern, we pull out a formula. So the general formula for what the interior angle sum of any polygon, so it could be a nanogon, which is a 9-sided polygon. You could just plug it into this equation and you can find it. So if I have a nanogon, which is a 9-sided polygon, 9 minus 2 is 7. 7 times 180, whatever it is, 7 times 180, that is the sum of the interior angle of a nanogon. Okay. Alright, so let's do an example here. So I want you guys to find x and give a brief reason. So ignore the answer right there, but I want you guys to give a brief reason. Okay, so if you added all of these up, so all the 3 x's, 90 and 132, so we want to know the interior, the sum of the interior angles, right? And lucky for us, we already have that formula. So we plug in 1, 2, 3, 4, 5 sides minus 2, that's 3 times 180, 540, and solve for x. You got 106 degrees. And do not forget to give a brief reason, or in my words, justification. So you need to justify in geometry always. So for me, the justification is sum of interior angles. That's how we got this, right? Alright, so let's move on to the next one. Okay, this is a weird looking polygon here. So solve for x and give a brief reason. Go ahead and do that on your paper. Okay, so I hope you wrote all of these numbers and add them all up together equal to, let's count, 1, 2, 3, 4, 5 sided. So that's a pentagon, and 5 minus 2 is 3, times 180 is 540. So you add them all up, x equals to 60 degrees. And do not forget the justification. Okay. Alright, so how about we do this here? So we talked about the insides of a polygon, but now we're going to talk about the outside angles, or the exterior angles. So write this down somewhere on your notes and highlight it. So there's a theorem, a fact in mathematics. It says the exterior angles of any polygon sum to 360 degrees. Write that down, box it. Okay, which makes sense, right? So how many degrees does something turn if you rotate it all the way around itself? 360, right? Okay. So on this example here, if the exterior angle A, this angle here, is 50, and then this angle B here is 120, and angle C here is 110, and we know that the exterior angles, so all of these added up together, is 360, so we can solve for D here by the exterior angles theorem. Sometimes I lose my letters here. That's okay. Okay. Oh, found them. Alright, example 4. It says a regular polygon has 15 sides. I don't even know what that's called. If a pentagon is 5-sided, I don't know what 15 sides is. Someone look that up. So calculate the size of each interior angle. So this example here talks about finding the interior angle, but we only know the sides though. That's tricky. So what do you think? So try that out on your own. Okay, so you might want to do this first. 360 degrees divided by 15. Okay, wait a minute. We're finding interior. Why are we doing exterior angles theorem though? Good question. Because of this. So once you know the exterior angle, you can find the interior, right? So look back at this. Once you know this, so let's say this is x, you are going to know this, right? If this is x, and this is going to be 180 minus x degrees, right? Because this is a straight line. So is this. Once you know this is just 180 minus that. So are all of these. So that's how you do it. You have to do it backwards, right? You need to use the exterior angles theorem, and then after that you subtract it by 180. That's how you get the interior. Alright, that was a good challenge question. Okay, so I'm going to quickly talk about Pythagorean theorem. We did this a lot in grade 8, but I just wanted to refresh you guys with Pythagorean theorem. So you guys know that Pythagorean theorem talks about a right triangle, and that the side opposite the right angle is called the hypotenuse, and these are called legs. And we know the theorem says that a squared plus b squared equals c squared, which means this side squared plus this side squared is equal to this side squared, right? And I've talked about this as well. This is the visual proof that this theorem is true, is that you can represent them with squares, right? So the area of this plus the area of this is equal to the area of hypotenuse, the hypotenuse squared. Okay, yeah, and then the sides of these squares are the legs and the hypotenuse. Okay. All right, really quickly, go ahead and calculate the hypotenuse of this right triangle here. You should get square root of 13. Okay. Technically, square plus minus square root, but again, this is a distance, so it should be positive. We're going to ignore the negative. Alright, so now instead of finding the hypotenuse, go ahead and find one of the legs here. You should get b equals to 3. And again, it should be plus minus 3 because plus minus square root of 9. But this is distance, so this is positive. Alright, so make it a little bit more challenging. These are the legs, and we're finding the hypotenuse. And the leg here has a surd, or a root there. Go ahead and find that. Alright, so you should get square root of 14, or plus minus square root of 14, and a review on root. Square root of 10, or the second root of 10, is the same thing as 10 to the power of 1/2. So they cancel out here. Okay. And then for b here, you get square root of 12. Or you can also make it 2 square root of 3. Because square root of 4 times 3, and this is 2 square root of 3. Just a little review there for you. Okay, and I want you guys to try this out. Example 4. It says find the value of y. So y is this leg here. Giving your answer correct to 3 significant figures. Let's see if you guys remember what that means. So as you can see, you have 2 triangles, so you know that it's going to be more than one step to do this. Alright, let's check your answers. You should get y equals to square root of 10. So let me go over that here. So we know that this equals to the squares of the legs, and then add them together, square root of 26. And then also we know that x, which is square root of 26, plus y squared equals to the hypotenuse square. So we solve that. The square root cancels out the square, and then you get y equals to plus minus 10, but in this case square root of 10. Plus minus square root of 10, I mean, yeah. Okay, so I hope you got all of them correct, and I'll see you guys in class.